find the heat absorbed or released, is what that stands for, when 10 grams of Na2SO4 dissociate. We're talking about heat, things I can always do when I'm in the heat unit. If they reference something that's a reaction, I can and should write out the reaction, regardless of what the rest of the question asks for. So Na2SO4 dissociating, that's taking Na2SO4 and breaking it up into its ions, a positive and a negative. Sodium is a positive ion, sulfate is a -2. Balancing it, 2 sodiums, 1 sulfate group, 1 sulfate group. There's my reaction. Something else I can always do in a heat problem if I have a reaction is find the heat of reaction, delta H reaction. That's when we did products minus reactants for these values using the chart. The one I gave you in class was pink one, like this. I don't know what color the one I gave you in class was, but it says the top standard enthalpy of formation. They give me in the question a delta H value, but notice it says delta HF. Delta HF is what's on that pink chart I just showed. That's the value for just Na2SO4, the value that should be on the chart but isn't. If you look for Na2SO4, you won't find it. So heat of reaction is taking everything into account. All of my products minus all of my reactants. These are my products, 2 times the sodium ion value. Ions are on the back. Pure elements, if they didn't have a charge, would be 0, but an ion makes it not a pure element. Sodium, Na+, has a value of -239.7. And then I have 1 sulfate, whose value on the chart is -907.5. Minus my reactants. The reactant value that should be on the chart is this one. I suggest simplifying what's in products and what's in reactants before you keep going, because where people really mess up on this stuff is annoyingly just the calculator work. 2 times -239.7 plus -907.5 is -1386.9. Minus negative, I just type it exactly as I see it, 1384.5. I get -2.4. -2.4. The negative tells me that the heat is being released by this reaction. So when we say find the heat absorbed or released, I know my answer is now released. If it were positive, it would be absorbed. -2.4, looking at the pink chart again for the units, is in kilojoules per mole. Realize I did all of this just from the fact that they mentioned Na2SO4 dissociating and heat. Now I know this is true anytime Na2SO4 dissociates. I will release, I don't need the negative because I know it means released, 2.4 kilojoules for every 1, because of the coefficient, mole of Na2SO4. Alternatively, if for some reason I wanted to talk about the sodium ion or the sulfate ion, I could use their coefficients on the bottom of what is about to be a proportion. That's how much heat's released if I use 1 mole of Na2SO4. Going back to the question, they want the heat. Find the heat. So how much heat if I use a different amount of moles of Na2SO4? That should also come from the question. So in the question, 10 grams of sodium sulfate dissociating, that's something I can turn into moles. Grams of sodium sulfate equals moles times molecular weight of Na2SO4. Na2SO4, you should get a molecular weight of 142. So my moles of sodium sulfate, 0.0704. Heat of reaction is for a generic or a coefficient number of moles. The heat specific for this problem is for a specific number of moles given in the question, even though we had to find it from the grams. multiplying, we get 0.169 kilojoules released. If you wanted to give your answer in joules, 169 joules released would be fine too.